Okay, so this is, anybody else doing multi-master right now?
When you say multi-master, you mean two masters to each other, or you mean multi-source?
Truly, well, either multi-source or multi-master, and we'll kind of distinguish them. But basically, you've got multiple masters accepting updates and either sharing them with each other or merging them into a single slave. That's a couple things that we've been working on. So these are just some slides. They're part of a commercial talk we do, but they do kind of talk about some of the basics. Continuent, yeah, skip over that stuff. We have great products. I'm going to talk about it after the conference if you want to buy some of them. In fact, this is some of the terminology that we use when we're thinking about this problem to prevent ourselves from getting more confused than we usually are. So there's basically three kinds of replication that we deal with. The first one is the classic master-slave. So you got one master accepts all the updates and then they get propagated in real time out to the slaves. And we do that a lot, and in fact, MySQL just does an incredibly good job of that and has for many years, so I think everybody's pretty familiar with that. But the other two that we want to talk about, or we wanted to discuss a little bit more today, are multi-master, which is where you have two or more masters accepting updates, often on different sites, and then sharing them with each other so that they get updated. And then there's this thing that Giuseppe likes to call multi-source. I kind of like the word fan-in for it, but I'm going to follow Giuseppe's line and call it multi-source. And that's basically where you have more than one master, which then are feeding a single slave. So these are the three kinds of replication that we work with. So here's an example of where multi-master is really important. I ran into this a few years ago. We had, there's a lot of people in the U.S. I don't know, is there online testing in Europe? I don't know how big that is, but in the U.S. you have these online testing systems. So for example, all the high schools in Louisiana, they actually do their high school testing on servers that are, they're like automated online testing, and it's all on these servers run by this company that's sitting in Monterey, California. That we did some consulting for a while ago. And one of the things about online testing is that many of the people who do it actually have multiple sites. And what will happen is there'll be some software that will download into your browser, and that software will run the test for you. It's sort of like a fat client. And what it often has is a list of places to go to run the test. And the idea is that if you're out there in Kansas somewhere, you can either go to Boston or you can go to Los Angeles to take your test, depending on which one is more available to you. And the idea is that the browser can decide where it wants to go. So that's a case where you have true multi-master, and what will happen then is you'll pick one of the servers and you'll go take your test there. And then it'll get propagated out over to the other one. So another thing that we see, and this is a customer that, this looks kind of hideous, but this is actually a customer that we've been working with for a long time. They're doing it's a hosted call center application, and that's where you have people, they pay, when you dial in to get product support or something, somebody picks up the phone, and these guys have built the whole, all the software that's used to do the call pops and stuff like that. And they have an architecture that looks kind of like this, where they've got some master data that's like the list of users, the customers that they have and some of the things about them. Those have slaves to back them up in case they fail. And then that master data then gets replicated down into the tenants. And so this is a case where they don't do, generally speaking, they want to be able to do multi-master updates on the global master data, but the tenants themselves are isolated to a single site. So those guys are not multi-master. This is one that we've seen. One interesting thing that they do is they want the tenants, like each tenant, to have a copy on the other site just so they could fail over to it if they really needed to. And then this is actually a very common one. This was actually taken from a customer we didn't get. These are actually ferry boats modeled. This is essentially the British Columbia ferry system. Looks like this. They have a Vancouver base, and then they actually have order entry for parts on the ferries. So I used British Columbia names, but in fact these are boats. that are going around British Columbia, and they do order entry, and then the stuff gets propagated into a fulfillment application in Vancouver that generates reports and also gets parts for them. So this is a very common one where people, you know, they've got remote sites, they're generating data, and then they need to combine it into a report. So you want to have like one slave receiving a bunch of stuff for all the masters. Any other, hope that seems pretty clear.
Yeah, I've had similar to your, similar to the boat thing.
The boat thing, yeah.
The big one is sales in the field.
Yeah,
Right?
exactly.
You have someone out in the field doing sales, and then they bring their laptop, and they might not be connected, and they want to be able to sync up when they come home or they get back to their hotel room or wherever.
Right, and actually that's actually a whole that whole sort of like portable devices, then syncing with the mothership. That's something that we haven't actually worked with very much, but like another customer that we some other folks we've worked with, like the U.S. Weather Service, had this problem in spades. They have about 50 weather stations around the United States, and then they do weather reports, and the data get propagated in. So that's where that comes up also. This is just a quick breakdown, sort of the different support. And I have to say, I mean, this is a technical conference. I don't want to BS you guys. This is the marketing distinction, but the deal with tungsten is the multi-master, particular things like multi-source we actually do very well already. And the more than two masters case, we're still really working on. So, just so you know where we stand, this is all open source software. When you run it, you'll find out for yourself. But the point is here that MySQL has kind of weak multi-master support, and it isn't going to get any better. They don't have the ability to do, in MySQL, for example, if you have more than two masters, you have to use circular replication, which really doesn't work. We know people who run it. I know Giuseppe has worked with folks that run it. It's very painful when things fail. And MySQL absolutely does not do multi-source. And I don't believe there's any...
Yeah, you can do round robin, but it's not the same thing.
I saw a blog article about that, and it just gave... I saw one article where you would stop it, and then you would go and turn something else on. There was another one where somebody figured out that they were using MyISAM, and they figured out some trick where they could replicate in almost like under the covers, and it was the kind of thing that just...
Yeah, what they were doing is they were rsyncing the data files because it was MyISAM, so you could just do that, and because they knew that it was different tables, then it was okay.
Yeah, and it was one of those things that just made my spine tingle.
Yeah, it makes my spine tingle just talking about it.
Yeah.
It should work, and...
Yeah, just because you can do something doesn't mean you should. So, so Tungsten, I think we've talked a lot about this. Tungsten Replicator is this fast open source replication engine for MySQL, and it's hosted out on Google. You can just go, search for it, and you'll find it. Here's the basic architecture of the replicator. We've talked about this a little bit. Actually, I haven't shown this slide at this conference, but it's written in Java, and it basically just sits outside of MySQL, and it can either tail the bin logs directly, sort of like doing a tail minus F, or it can dial up to MySQL through port 3306, if that's what you're running on, and just download stuff. Like, for example, the downloading, we can do, I wrote the code that invokes it, but it's based on some really good work that Jill did to handle the MySQL client protocol. So what happens is it gets downloaded. We put it in our own transaction history log, and one of the things that's interesting about this log is that it basically contains a bunch of metadata that MySQL doesn't have. In fact, most people don't have. So, for example, we have global transaction IDs. The first transaction we pick up, that's transaction 0, and we just keep numbering them incrementally until we run out of integers. We use a long, so it's probably...
Does that happen ever?
We will all be long dead, and our graves will have disappeared by the time we run out of
64 bits.
Yeah, it's 64 bits. I think I did the calculation, and for, with anything like, unless you have like an amazing increase in storage capacity, you're talking hundreds of years before you run out of numbers.
Now, would that theoretically, when that happens, like if you, let's say, restart Tungsten Replicator for whatever reason, maybe you've patched the operating system so you had to restart everything on that, does it start with 0 again?
No, it remembers where it is.
Okay,
That's
so
the
if you
number
run
stored
out,
per system.
You're out of luck.
You're out of luck. But it's a big number.
Didn't you say you start from 0 and then you increment?
Yeah, increment by 1 for each
How does
transaction.
it work with multi-master?
Well, that's it. Well, I'll show you in a minute. What happens is the trick with multi-master is we are truly multi-slave, or excuse me, master-slave under the covers. So what we do is we have services going both ways, and it has some advantages. One advantage is you can get it to work without having distributed consensus. The disadvantage is sometimes can be very hard to
So you have a
debug
single
problems.
point where you assign the numbers.
Excuse me.
So you have a single point somewhere in the middle where you assign the numbers.
Actually, the numbers are always assigned on the masters. And then what happens, I'll show you a picture of how we do multi-master in just a second. That'll show it. And then then the arguments can start. So, because I said that was one of the things. So here's some of the stuff that the Tungsten Replicator does. It's a bunch of stuff, but we really want to focus on multi-master replication.
You're going to have to change your slide to say to MongoDB2.
Yeah.
You know, and actually,
No, it says from.
Linus is, I mean,
Oh,
this
that's
stuff is
true.
changing on a daily or
Yeah,
almost
from
hourly
MySQL.
basis. Because Linus also got, as he was discussing,
Yeah.
he's got Postgres to Postgres replication going as well.
It is so.
Yeah, so,
That's okay. Yeah, it says from.
yeah, we can do, and you know, well, anyway, this stuff is so much fun to work on. I got to stop because I'm going to rattle on something unrelated. So, building block, replication services. So one of the things that problems that we've run into is that, you know, from just a problem perspective, you tend to want to have multiple replication flows, particularly when we're talking about multi-master. I mean, data are flowing in from multiple masters into a slave. There's also another issue, which is that this stuff is all written in Java, and Java is kind of fat. It's not like these lean and mean, you know, executables that you compile yourself. So, so for those two reasons, we actually have these things inside the Tungsten Replicator. You can do more than one replication flow at once. We call this a replication service, and it works kind of like an app server. You know, if you're familiar with it, Java has this model where you'll load web apps into Tomcat or JBoss or something like that, and then they'll run independently. So Tungsten is kind of similar to that. You have these independent services. There's some in the internals. It's all out of one class loader if you're a Java if you're interested in Java. So it's not quite as isolated as an app server would be, but it actually doesn't need isolation as much. And the idea is that you have these replication services. They have separate administrative interfaces. Because this is Java, we use something called JMX. Linus just put in some support for JSON using this really cool library called Jalokia. So these will be shortly also be JMX interfaces, and the idea, or JSON interfaces, and the idea is that you have a main service which, you know, keeps track of all the other replication services, and then there's a separate administrative interface for each of those guys. And this actually shows you then at a high level how we implement multi-source replication. We just run two services and they can run in the same replicator, suck data out of New York and Frankfurt and put them into San Francisco. So one of the things to kind of build up to multi-master was we cooked up this notion of local and remote replication services. And the way that they work is that you can imagine that you have a replication service, and here you have, it's called NYC, so imagine this is in New York. This replication service is the thing that's responsible for sucking the transactions out of the bin logs generated by that server. So it's the guy that makes that thing a master. And then let's imagine that we maybe have transactions coming from another master. Those are delivered through this thing called a remote service. And so what happens is they come in, and in MySQL, the way that we handle this is the remote services, everything that comes in gets logged, including metadata. Stuff like Tungsten maintains a little table that helps it remember what sequence number it got to on the slave. So all that stuff gets logged, and then it gets pushed into the bin log of the slave. So you basically have two services operating in multi-master. You have a local service pulling from the bin log, and then you have one or more remote services that is bringing things in from other masters. Does that make sense? It doesn't always make sense to me, and I think there's some question about whether this is absolutely the right model. We may tweak it a little bit over time.
Does it end up serializing the stuff?
Absolutely, yeah. We're like huge. I'm personally like a huge serialization guy. I think that everything we do is serialized. Our starting assumption is you have completely, perfectly, beautifully serialized transactions, and luckily for us, the bin log just does that. I mean, this is one of the triumphs of MySQL replication, is that it gives you transactions in serial order and you just read them. And then everything follows from that. If you're not serialized, it's very, very difficult to get a lot of these tricks we do to work. So yes, we're totally serialized, we stay serialized, we play games by splitting things up, like for parallel replication into separate streams, but those streams are also serialized because they came from a serialized source. So here's how bidirectional replication then works. Here's a setup that we've tested. Your demo doesn't show this one, right? You're going to do a different one?
I have this one as well.
So, but basically what it does is you've got the San Jose site, and you got a master and you got a slave. You got a New York site, you got a master and a slave. There's bidirectional replication between the masters there's a local service that pulls out of the bin log that feeds the San Jose slave. There's also a local service in New York that feeds the New York slave. And what's kind of interesting is that, see how these remote services, like if you look at do you have your pointer handy? My finger's not long enough.
Where did I put?
Yeah. Right. So these, I'm starting to see the benefits of these. So what happens when, for example, when stuff gets stuck into New York, somebody commits a transaction there, it gets pulled out by the local service, it flows down to the local slave. That's no big deal, we've done that for years. But the key thing is that it also gets pulled by this remote service, which then goes ahead and applies it to San Jose. And then what happens is it gets pulled out again by the local service and sent down here. This thing down here, what's happening is not only do the transactions that were written get applied, but the metadata about where our position was with respect to New York, that gets pulled down as well and applied to the slave. And I'll show you in a minute why we do it that way. But first I want to talk about preventing replication loops. So replication loops are kind of a problem. MySQL solved this really well. They have a notion called a server ID. It gets written into the bin log, and so when stuff shows up in the, over on a particular server, MySQL will just look at it and say, hey, is this a server ID that I'm at right now? If so, I'm going to throw it away. So we do a similar thing, it's just we don't quite have access to server IDs. Because it turns out that, we have to do everything as a client, and it turns out server IDs can only be set from within the server itself. You can write a UDF that gets around that problem, but we're not using that in Tungsten yet. So replication loops are obviously where the transaction keeps bouncing around between the masters, and so Tungsten allows you to filter stuff. That was the basis of some of the stuff we did with Mongo that Stefan has this code that, for example, can add column names. Another thing a filter can do is it can look at SQL and decide, hey, this should not be applied here. Let's throw it away. So basically we have this filter called BIDI remote slave filter for bidirectional, and it just looks at the transactions, decides where they come from, and throws them away. I can't remember if I have a slide that shows how we do this, but basically what we do is for statement replication, we put a comment in the SQL that says where it was originally generated. And most SQL generated by MySQL will preserve that comment as it moves around. There's a few exceptions. If it's row updates, we have within those row updates, there'll be like a metadata update that we put in, and that also enables us to tell where it originally came from. So that's how this works. Resolving conflicts. So we don't do conflict resolution yet, but the weird thing is, in a way we do already, and I'll explain how that works. So obviously if you were doing multi-master, you'd have to deal with this sort of trivial stuff like key offsets. And I think in previous times, people would make a big deal of this, but the fact is, in multi-master replication, this is like so simple, and such a small fraction of the real issues in multi-master. The problem that you get is there's just a huge number of ways that things can conflict in multi-master. So you can have, and most of them can only be resolved at the application level. So for example, you can have you could have an accounting system where you update something in one location and then you simultaneously update it in another. Well, it could well be that the update could only happen in one location because that's the person that owns the account. There's conflicts like that where the replication should just say, hey, I see you were trying to do this on the wrong site. I'm going to reject this change because you're not allowed to do that. So the conflicts can go very, very high up the stack in the application. And at the database level, there's very little you can do to handle those automatically. You can do sort of obvious things, like use natural keys, don't write to the same tables or databases. That's an easy way to avoid conflicts. And you can certainly, you end up having to think about it in your application quite a bit. Now, Tungsten has, as I said, is beginning to do conflict resolution. And the first example is this anti-looping filter is a really good example of a conflict. If we allowed this thing to go zooming around, it would just sit there and loop forever, but we don't. We stop it because we recognize that would cause a problem. So one of the things that we'll be doing over time is, like, the next level of filtering would be to add a very simple filter that says, hey, these tables are owned by these sites. And if we see an update on a table on our site coming from somewhere else, we'd say, no, we're not going to let it in, and we're going to put an error in the log or signal it to somebody.
Could you even block it that you actually kind of write the MySQL?
Well, that's an interesting question. We have proxies in our commercial products, and that's eventually the kind of thing you'd want to do. I actually think more deeply than that, it's probably time, it's time to start thinking about changing the database semantics as well. And as we get into, multi-master is the first place that I ever wrote a UDF. I've written a couple of little ones, which we'll be publishing pretty soon. And this is where you actually want to hack the database a little bit, I think, to like be able to enforce that. You could use security as well. I mean, there are tools in there to do that. And then there's.
But there is no reason why the filters couldn't do that.
No, there's no reason why filter. But the thing is,
the problem is the filter can prevent from replication, but then you have.
But the damage is already done.
You screwed it up.
You screwed up one database, and that's actually a really key issue. We can stop you from making it worse, but we can't. It's sort of. I think one of the things we say is with multi-master replication, it's your gun, it's your feet. We've given you the gun, and you just have to avoid not shooting yourself in the foot with it.
It's a machine, yeah.
Yeah, and it's
conflict resolution means many things, and once with Massimo we were in Spain and he was scratching his head for 2 hours. We said, and so what you don't do here. Now you can kind of split or separate tables. These tables I can write in this side, but what if I actually want to write to the same records from multiple sites, and then I want you to provide a functionality in the replication where you say that, for instance, if the timestamp column is larger in one place, this is what it will end up.
Right, and there's troublemakers like you in every talk that we do. No, that's exactly what it is. Everybody wants to write to the same table because that's what you need to do. And I think that's exactly the kind of thing that we want to do, which is that, we have these filters which are very powerful. We're sitting there, we have, particularly if you have row updates, which are pretty easy to manipulate, you're holding the row, you know exactly what the person did, you know the column names, thanks to Stefan's filter. You can make some pretty sophisticated decisions. So what most products, like if you go and look at what Microsoft SQL Server does, they have callouts that allow people to insert their own scripts. So for example, we did a JavaScript adapter. That was something Linus put in a while back. You can actually write a JavaScript to make decisions like this. I think there's also certain very common patterns, and one of them is the timestamp. And one way I was thinking we could do this, have a kind of Ruby mentality, that if we see certain columns with certain names, we would say, aha, that's the timestamp that is meant to control, access. If we see that column, and we can because we can see the metadata, we know the column name, and we know what type it is, we could then dynamically recognize, hey, that's a table that should be protected using times, last in succeeds or something like that, like latest change assumes.
Of course, life isn't always simple, so if I have a big transaction that updates with many records and tables, and they all have timestamps, but but in some simple web application, it often happens that I update one record.
That's right. And it can be just that simple. I mean, we can also help you with the timestamps because we can read them out of the bin log. You don't even have to even set them necessarily. We can read the timestamp data, like the time it posts into the bin log, and generate the timestamp
of the transaction.
Yeah, so that we have out of the bin log. It's in the header.
So why isn't this used already? It's been there for 10 years now.
Well, it's just waiting for us to come along. So there's a lot of opportunities here.
The answer is because in replication it's serialized and it's pulled from the slave. So there's no way to pull more than one from the slave, right? Because it's only one thread of the SQL executing from the relay logs.
No,
and only
even
one
in MySQL you can do circular replication.
Yeah,
but each slave only has one master, and because you can do that, because you could say, because what you're saying is, why don't we have a slave that has two masters, and then it just writes to the relay log, it has a timestamp section of the relay log, and that's where all the things for one timestamp get put into that section, and then whatever. But because it's
no, I could even today, if I set up circular replication and my application writes to all the databases. That's why people just write to one database.
I know.
But I could write to several.
But
I sometimes would.
I was responding to something else you said. Why don't we have?
I'll tell you,
what this is?
I think actually a big reason why it hasn't been done up till now is the Tungsten finally gives you call-outs, because the key to solving these multi-master problems, again, this is just based on looking at what people like Microsoft and Oracle have done about this problem. It almost always ends up to be some callback where there's a piece of logic that decides should this transaction be applied or not. And that call-out or callback didn't exist in MySQL. I mean, there's a lot of talk about putting it in. It just never got in. We've got them, so we can start to attack the problem.
But actually, so the timestamp in the binary log is fine, but actually you need to compare against the data that you have in the database. So
that's correct.
You still need to have a timestamp in the schema.
That's right. You need to have it in this. You need to have it in the schema. So I think, and that's why I think if we use like a Ruby thing where we just say, hey, there's some conventions about how you set up your schema. As long as you name things a certain way, we'll recognize them automatically as being fields that we should use.
And if you're the first one to do it, you get to pick the name.
Yeah, exactly. So the one thing I should say is that, and we've had this discussion on your blog, is that the one thing that I find a little creepy about this is some of these algorithms, we're going to have to work on them to make them fast. So for example, if you imagine every transaction that comes in, you got to go look in the database and see what the existing data look like. That's going to be kind of pokey. I mean, you're talking, that's going to really slow you down to being able to process, like a couple hundred transactions a second.
But now you do update statement when you.
Yeah, we do.
So you do update blah blah blah, and where timestamp is larger than.
That's in. Could you make a note of that? Yeah, that's a good idea. We could let SQL make the choice.
So you don't need to first read it.
Yeah. So.
This is I learned this from back home. So also when you update stuff, the row is actually read under the hood. It just doesn't magically sink in somewhere.
Yeah, absolutely. So that's what. Yeah, we could do that. What that would mean is we'd have to change the applier logic a little bit.
But that will only work for updates, not for inserts.
But inserts are new rows.
Yeah, so there
are no conflicts as long as the table exists.
Deletes are actually an interesting thing. Is deletes like how to get? I mean, there's just like a bunch of cases. There's a lot of case logic here that we have to handle. But that's an interesting. That's a good trick.
Update delete is more difficult because then the timestamp goes away and you don't know if it was just deleted or if it wasn't yet inserted.
Right. Okay, that's a great trick. Actually, so I should say failover and multi-master. So this is another interesting topic, is how to do failover when you have multiple slaves. And just to make it a long story short, here's how we do it now. We may cook up a better way. I mentioned that, so here's this, like a San Jose site, it's receiving stuff from New York, it's also generating its own transactions. As I said, they get replicated down, including the position of the stream coming from New York. So if we had a failure of this host, let's say these guys are running on one host, they die, what can happen is we bring up, basically we'll promote this guy to be a master, so that's step one. So he becomes a master, and then this remote service, we've got enough information that we can just fire up a remote service and begin slaving off New York again, and we have a restart position. And that's the whole key of these multiple services. They remember their restart position, and this is a key thing in replication so that you can fail over correctly. That's how that works. So some best cases, and I think we're going to have a demo here in a second, right? Have you got something?
It's up to you.
Or up to you guys if you want to see a demo of it. It's Giuseppe has a cool one. Here's some of the multi-master best cases. Cross-site distribution of global data. So often it's not a lot of data, so you're not bound, terrifically dependent on having them be applied very quickly. The multi-source replication we do really well. Now we don't do conflict resolution, but typically in multi-source stuff it's more like you're aggregating stuff for reports, so less likely to have conflicts anyway, because you might have different tables for different offices or different keys. And certainly the thing that we're working on really hard is to replace MySQL circular replication. That's a really big topic. Something where you can add and remove nodes to multiple masters on different sites, and you can actually have proper failover. So that if a site goes down, you fail over correctly. And basically what we're going to do, I don't think I have a picture of it, but we're going to implement a form of what's called star replication, where you basically replicate, everybody's generating logs, they all go to a central replication, or a central point, collection point, and then they get replicated out again. So, and then there's a way to, if that central point goes down, there's a way to switch and go to another host. So that's all stuff we're working on. Yeah, worst cases. There's some, multi-master, if you didn't have to do it, you wouldn't, because it's actually kind of nasty. Right scaling, there are some people who think they can use this as a right scaling solution. Of course, it doesn't work that way. You end up doing the rights in both places, so it doesn't help at all. Single site multi-master, God only knows why you'd want to do that. This is typically something you're doing across sites where you really can't, because what you can do is if a single site multi-master, I'd want to ask why do you want to do that? Because you can just have one really powerful master server, and it's so much simpler. And then multi-master on the same tables, this is the one that everybody wants, and that we're still really noodling about how to get it. And hopefully I'll be able to write a blog article in a couple months, because we've got to put it through. And then we'll have some advice on how to do that one. That's one that I think we will get. But these other guys right here, we're probably not going to. The first one especially, we won't get them.
Robert, a lot of people do single-site multi-master in the sense that there's only one primary write server.
Yes.
Just so that,
So you can do
master as in active rights.
Yeah, the old like the stuff that.
Basically,
like
so that when
Jeremy
you propagate the slave to a master, there's no work to be done. You just do the rights over.
Exactly.
Now, with you guys and things like, one of the things that you mentioned that people do is, with MySQL, is change the auto increment and offset. Now, is that something that you guys also do? One of the problems for me with the auto increment offset and auto increment is that it's for all tables.
Right.
And some tables, might be small, it might be a tiny int, and it might be something that you're not going to write to both. So is that something that, I know you guys do it completely differently, but is that a problem that you guys would run into using using the way that you guys replicate too, because those things are global.
Those wouldn't, you know, see, the thing at that level, we're just dependent on how MySQL works, and so we're, you know, whatever, in that sense, I don't think there's any difference between what we would want and the way you'd want to do it with regular MySQL replication. So I'm not sure we have a strong opinion either way. And let's put it this way, we don't make those problems go away.
Right.
That's
the problems happen before they get to you.
exactly. That's a good way of putting it. So Giuseppe's got a demo, haven't we?
So the demo that we are going to do is bidirectional replication with slaves, the one that Robert mentioned first. And how does it work? We put several services. So we have Alpha and Bravo that have two services. Let me see directly. In the first host, we have two services. One is the master and one is slave. So master of Alpha and slave of Bravo. In the second server, we have the opposite. Slave of Alpha, master of Bravo. Then, on the third server, is just a slave of Alpha, and the fourth server is a slave of Bravo. So what happens when I do some changes in Alpha? It will replicate to Bravo, and from Bravo it will go to the fourth slave. And when I put data in Bravo, it will replicate to Alpha, and from Alpha it will go to the third slave. So I have inserted 100,000 records in Alpha in table T1 and 100,000 records in Bravo in table T2. And they are replicated bidirectionally, and from these two they have expanded to the others. I think I've shown the multi-source yesterday during my talk. Have you seen that? You want to see that again? Or if you have any particular desire,
Yeah.
I can try. So we have the multi-source where we create.
Hey, sorry, now I just realized what I'm saying. So what is this application you use to?
It's a simple shell script with dialog.
Okay.
That will.
This is your own tool that you use to set up different.
Yes, and this is in the source of everything that I'm showing here is in the Google code for Tungsten Replicator, so you can try this on your own.
Okay, that is helpful.
This is basically a testing environment. So what this shell script does, it will erase everything in 4 servers and then start 4 replicators from scratch every time. So
are they different servers or everything on your laptop?
I can do the same. In my laptop, I can run up to 6 virtual machines with the generosity of Continuent who allowed me to buy a powerful computer. But these ones are in real servers in Germany.
So this is like MySQL sandbox for Tungsten.
This one? No, this one are real servers. Oh,
Yeah,
no,
but
no,
I mean
no.
like
The sandbox for
your
Tungsten is
project.
coming.
Yeah, well, he's working on it.
Yeah, because now I have to use tricks for that. I have to use virtual machines. I want to do that everything in one host. So this is what we have done so far in this script. I created 3 masters and they replicate to a single slave. So instead of having 2 masters here, we have 3. Every master does something in a different table. And the slave has all the 3 tables with 100,000 records each. By the way, this 100,000 records is just one huge query with 100,000 records in it. It's a huge insert. It's not 100,000 inserts, otherwise it would have been too slow. But this is cool to show. So, any questions? This is the end of the allotted time.
Your 3 masters, do they need to have, when you do this and then you replicate to one slave, do they have to have the same schema?
No, you need to have a compatible schema between that particular master and the slave.
The slave, yeah.
So you can replicate from one particular schema that is in host 1 to a particular schema that is in the slave, and the same happens for the other masters. In this case, I have only one schema, that is schema test, and I use it 3 different tables in the same schema. So the only, as Robert mentioned, the conflict resolution is a responsibility of the application. So the application in this case says master number 1 will only deal with table T1, and master number 2 will deal with table T2, and so on. So it's very easy to avoid conflicts, this one, but it needs some discipline.
When you have 2 masters that talk to each other,
Yes.
do they need to have the same schema, or can you also, on the level of the application?
Same thing.
Same thing, on the level of application.
Actually, when you have 2 masters talking to each other, they eventually will end up having the same schema, because what you change in slave 1 will end up in slave 2, and the other way around. So at least for the things that you start replicating in a bidirectional way, you need to have the same schema.
Although, I should add to that, Linus has done some really good work on, because of the MySQL to Postgres stuff that you did, where we use JavaScripts to transform schema, and I think that it's something that we can do fairly efficiently at this point, but I have to say the code is a little hard. I think I'm thinking about doing a little bit of a rewrite on some of the classes to make it easier for other people to program. And at which point, you can fairly easily write a script that says, hey, drop this column, for example. Like, we have the column name filter that, puts that information in, and it's really not very hard to do.
We could have
because more than replication, I'm thinking about data integration.
Yeah, absolutely. And I think, actually, the number one thing, as I mentioned in the keynote, or the short talk I did yesterday, I think that one of the really key things is to have some real, almost like table-driven data transformation capability, because where you don't have to write an extensive program to make standard schema changes like dropping, adding, merging of columns. And that's definitely, as soon as we can find some software or write it ourselves that will do that effectively, we'll have that out there.
Enric, this is what that program does. It's like several lines does, but this is with a shell interface. So the end result of this will be a script that is called TMP topology sh that is created from that, and this are the commands that are necessary to install the topology that we have chosen. More questions? You want to know when lunch starts?
I think it starts now.
No, it's in
One
one.
more session.
Oh, it's one more. Oh, okay.
Okay, so no more questions. Thank you.